Hello and welcome to our series of tutorials, and let's continue our discussion of PBR materials. So we were looking into roughness maps, and let's go back to some other color that you can see the roughness easily. See, so you can see that at some point the surface is rough, other points it is glossy, and yeah, we should always go to sRGB because that's the correct color space for if you want to exactly see how the image looks like. And as you can see that the surface is rough and glossy at the same time because of this map. Other options are similar, so we are not going to go into those details. Now let's go to the metalness property. Let's see if I make this very metallic. As you can see, the entire surface is metallic. It's just that because we have this roughness map at different point, it is showing high or low roughness. So first, let's remove this image. So it is completely rough because now roughness is 1. Now let's draw the same checkerboard image on the metalness map. Let's see how do we see it. Okay, and the metalness sampler, sRGB color space, and make it 3 to see clear. And here, as you can see, that there is this light and gray areas. To see it more clearly, make the roughness 0. And now this is the part where basically metalness, you can think of it as if metalness was 1, the surface acts like a perfect mirror. So as you can see that these areas, they are acting as a perfect mirror. Whereas, so you can clearly see the environment map. You can see the curtains, the lights here in this part. Whereas on the lightish areas, it's not very, very clear. It's not acting as a perfect mirror. So, and of course, metalness, you can make it 0. If you make it 0, that means the entire surface has become non-metallic. Whereas if you make it completely 1, the entire surface has become metallic. So if I remove this, then everything will act as a mirror. So if I remove this, as you can see that everything is reflecting perfectly. Whereas if I apply a map, again, sRGB. So that's an importance of, metalness map. Now let's go into some other properties like bump or normal map. Let's first go to the normal map. So for that, let's remove the metalness and we will apply a normal map. So I'm going to apply a normal map here. Just drag and drop a file. It can be a PNG, it can be a JPEG, or WebP format. Now, as you see in this, the surface originally was very smooth, and the normal map, what it does is it changes the way the surface reacts to lighting. So it appears to be more irregular right now because of this normal map. So this normal map, applying a normal map is a very good trick in order to give more details to your surface without increasing geometric complexity. So see that? It appears that the surface is very bumpy in this case. Or we can decrease the metalness, and you can control what is the scale of your normal. So I make it 0. It's perfectly smooth. Make it slightly. So you can control the scale of normal map. Other parameters are same for the sampler. Right now we don't want to go into the details of object space, not tangent space, but by default, if you see a normal map which is bluish kind of in color, then almost bluish, then it's basically in tangent space. That's like a very vague way to understand tangent space and object space. I will not go into those details. Let's try another normal map here. This is a bit different kind of pattern. As you can see, let's try something else, like stripes here. So as you can see, normal map can give interesting details to your object. And then you have options of bump map. So bump map, you can understand it as a kind of an alternative to normal map, but instead of the image in this bluish kind of a shade, so for instance, this was a normal map. This is also a normal map. This one. Instead, let's try to apply this as a bump map. So bump maps are always in grayscale, and the purpose of bump map is also same. You can simulate or add more details to the surface without increasing the geometric complexity. Let's do that. As you can see, the bump map is applied. Increase the sampling. Step 5. And you can control the bump map scale by this slider. So again, now you see that it appears as if the surface has these details, whereas there are no changes in the geometric normal of the surface. So that's kind of an overview of a few more properties in bump and normal maps and Metalness map. We'll continue our discussion of these properties and more usability of these things in the next few tutorials. Till then, thank you so much for watching.